What's up everyone? Today was a mix of everything. Polishing my public profile, beefing up my YouTube automation scripts, and then diving headfirst into some classic LeetCode brain teasers. Stick around to see how it all unfolded. This is day 52 of coding every day until I hit 1K subs. Today, I kick things off with some updates to my YouTube series automation scripts and my personal portfolio, then jumped into a few LeetCode problems. Let's get into it. First up, I made a few tweaks to the Python script that helps me put together these daily videos. There was a cookie update and a code.md update, which likely means I've refined how the script handles web data or session information, and how it organizes code snippets for the videos. I also pushed some editorial web scraping improvements which should make gathering content for LeetCode explanations a bit smoother. And another commit mentioned a big LeetCode video update, indicating some more substantial enhancements to the video generation process for LeetCode segments. All about making this series creation more efficient. I also spent some time updating the README on my main GitHub profile. It's important to keep that fresh, showcasing what I'm passionate about and what I've built. Let's take a quick tour of the updated sections. So here's the intro. A bit about me, my focus areas like AI, NextJS, Python automation, and even FFmpeg for video stuff. Next, I've listed some websites I've built, like a Thai learning app, my Buy Me a Boba page for support, and a custom biotool for a client. Then, there's a section for Python packages I've published on PyPI, including tools for image detection, interacting with LLMs, and improved text pasting for automation. I've also highlighted my Cline X projects for cost management with AI APIs, a Chrome extension for Gemini, and a VSCode extension for Codespaces, plus a little apps coming soon. Teaser. Here's a snapshot of my tech stack. Languages like JavaScript, TypeScript, Python, frameworks like NextJS and Expo, and various tools I frequently use. The README also includes my GitHub stats card, showing off my contribution streak and other metrics, always motivating to see those numbers go up. And of course my LeetCode stats card, which tracks my progress on solving problems there. It's a nice visual summary of my LeetCoding journey. Separately, I also made a quick caption update attempt for my promoting-hardstyle project. This is likely related to tweaking text for social media posts or content descriptions in that space. Just keeping all the side projects ticking along. Alright, shifting gears to LeetCode. First up is problem 1061, Lexicographically smallest equivalent string. Spoiler alert, the problem asks us to take two strings, S1 and S2, which define character equivalencies, like A is C, C is E. Then, given a base str, we need to transform it into its lexicographically smallest equivalent version based on these rules. This solution uses a union-find data structure to manage equivalencies between characters. Each character is initially in its own set. When an equivalence is declared, their sets are merged, with the lexicographically smaller character becoming the representative of the merged set, thanks to path compression and a specific union strategy. For the base string, each character is then replaced by the representative of its set. This approach efficiently handles the transitive nature of equivalences, offering near-linear time complexity, specifically order n plus m, where n is the length of the equivalence strings and m is the length of the base string, with constant space for the alphabet. Next problem. 3403. Find the lexicographically largest string from the box I. Spoiler incoming. We're given a word and numFriends. The word is split into numFriends non-empty strings. We need to find the lexicographically largest string that could be one of these splits, considering all possible ways to split the word. My first attempt for this one involved generating all possible substrings that could be the first friend share, by iterating through all possible start and endpoints, while respecting the maximum length constraint. Then I'd pick the largest. This turned out to be too slow and resulted in a time limit exceeded. The accepted solution is more direct. It iterates through all possible starting positions I for a substring. For each start, it considers the longest possible substring that can be formed, which has a length up to n minus numFriends plus 1, ensuring that the remaining numFriends minus 1 friends can each get at least one character. It then takes the maximum of all such generated substrings. The time complexity is primarily driven by iterating n times and then slicing and comparing strings, roughly order n times l, where n is the word length, and l is the maximum possible substring length. Alright, on to problem 135. Candy. Classic problem. Spoiler alert, there are n children in a line, each with a rating. We need to give candies to them, such that each child gets at least one, and children with a higher rating get more candies than their immediate neighbors. We want to find the minimum total number of candies. This problem is solved using a greedy approach with two passes. First, every child is given one candy. In the first pass, iterating from left to right, if a child has a higher rating than their left neighbor, they receive one more candy than that neighbor. In the second pass, iterating from right to left, if a child has a higher rating than their right neighbor, they are considered for more candies. Specifically, their candy count becomes the maximum of its current value, and one more than their right neighbor's candy count. This ensures both left and right neighbor conditions are satisfied. This two-pass strategy correctly assigns the minimum candies in order n time, using order n space for the candies array. Last LeetCode for the day, 2929. Distribute candies among children. 2. Spoilers ahead. We are given n candies and a limit. We need to find the total number of ways to distribute these n candies among 3 children, such that no child gets more than limit candies. This solution counts the ways to distribute n candies to 3 children, with each child receiving at most limit candies. It iterates through all possible numbers of candies the first child can receive, say I candies, from 0 up to the minimum of n or limit. For each amount I, it calculates the remaining candies. Then, it determines the number of ways to distribute these remaining candies between the other 2 children, ensuring neither exceeds the limit. This is achieved by calculating the valid range for the second child's candies. They must take at least 0, and also enough such that the third child doesn't exceed the limit, and at most limit, or all remaining candies. The number of integers in this range gives the ways for the remaining 2 children. The overall time complexity is order of the minimum of n and limit, using constant space. And that's a wrap for day 52. We went through some project updates, polished the old GitHub profile, and tackled a few interesting LeetCode problems. If you enjoyed this, please hit that like button, subscribe if you haven't already, and let me know in the comments what you're working on, or if you have any thoughts on these problems. Any support for the channel over at buymeaboba.com, link in the description, is always hugely appreciated. Catch you in the next one.